Hello, everyone, and welcome to the PT2020 Programmable Pneumatic Pump Control Box webinar. I'm Tamer Mutkur, and I'll be joined today by Joe Daniski from our engineering department, and we'll be tag teaming this webinar together. If you have any questions, there's a chat box that you can enter your questions at any time. We're not going to answer those questions until the end of the session. So we're going to go through our slides. The last slide is some Q&A, and then after that we'll go through your questions. So please, if you have any questions, make sure you enter those in the chat box. So the PT2020 is recently getting introduced, and it's our first plug-and-play control box for intensifier pumps that allows you to automate your process. The box has a pan protect pending currently on the box. And this basically allows you to automate your test whenever you're doing any hydrostatic testing. So it takes any guesswork when it comes to a pass-fail criteria. And not only that, but gives you a downloadable report that you can hand over to your customers. So it's important to highlight some of the history behind this product. This was a collaboration of 4 prominent companies that came together and put a lot of history and a lot of product knowledge and design into the PT2020 automation box. This collaboration is between Graco, Sprague Pumps, High Pressure Equipment, and Astrogauge. So again, it's the industry's first electronic control automation box for high pressure intensifier pumps. The box is going to allow you to record your pressure test. So it takes all the manual work out of it. It's an easy to install, whether it's new or on an existing test bench, and it's plug and play, so it's a really easy interface. It's a touchscreen interface that allows you to enter in your parameters, start your test, and walk away and let the control box do its thing. There's a manual mode and a pressure test mode, so you can run the box in those 2 modes. And the control box can be utilized with any high pressure intensifier pump in the market. So our target customers and applications on the OEM side, these are folks that currently spend the majority of their testing doing it in a manual fashion. Now you're given an automation box that allows you to reduce your time and give you the confidence in your reporting, and then also give you time to address other things in your shop, allowing you to have very little downtime. The box is programmable, so it takes any guesswork out of your process, and you can also customize your reports and it also allows for an automated pass-fail criteria. Other target customers are going to be rental companies that allow for portable pressure testing. So whether it's in a lab or on a portable piece of equipment, the control box can fit those applications. Next, I'd like to turn it over to Joe, who will talk about how the control box works.
All right, hello everyone. So to start with this system, remember this is an automation control box that allows you to do 2 things. One is control a pneumatic pump. It can also be installed on a pre-existing manual test bench and allow you to run that system automatically. So basically this bench would replace the manual controls that are already installed on that system. So how does it work? I'm going to use my cursor and I'm going to go through some of the key features of this system. We have that control box. You've seen some pictures of that in previous slides. On the front of that control box is a touch screen, which allows you to interact with the unit. You can enter pressures, start, stop tests, things of that nature. To install a system, you first connect power to the box, which is this cord on the top of the box. And then on the bottom of the box, you feed your air line in. So we have an air filter to protect the valving inside the system. And inside this box, we have an air regulation system which controls the pressure to the intensifier pump. So connect air to the box. We're going to manage that pressure to run the pump. On the outlet of the pump, we install a pressure transducer. So we also monitor the actual fluid pressure that that pump is generating. We send that signal back into the control box, and based on the reading of that pressure, we'll know we're either above or below the target, and we'll adjust the pump accordingly. So what we actually do is we do that measure and test function very quickly. We do that about 10 times per second, and we'll constantly adjust that pump to ultimately drive it up to a specific test pressure that you're asking for. And then when we achieve that pressure, we'll do various things, like we could hold the pressure, we could do a decay test. There's a few options that we could do. As far as input air pressures, we want to make sure that we can supply enough pressure to run any pneumatic intensifier pump that's out there, and that's a pressure and a flow requirement. So we can handle air pressures up to 146 psi and also 85 SCFM. So that should be plenty of air pressure and flow to run typical pneumatic intensifier pumps that you see in the field. So moving on, how does the software work? We have two different ways we can control the system. First is manual, and I'll get into it in a couple future slides, but basically there's a plus minus button for pressure. And it's very similar to if you were to run a manual regulator and just turn the regulator up to increase the air pressure to the pump. In this case, on that touch screen, you would just be hitting a plus or minus button to increase or decrease the pressure. There's also an automated pressure test feature which allows you to do some really cool things. You can basically set up a test in the machine. For example, say you want to do a pressure decay test at 10,000 psi. You can tell the unit to drive up to 10,000 psi, how long you want to hold it for, how you want to measure your test. When that test is completed, it'll determine if you passed or failed that test. So everything's automated. Think of it, you set up your test, you hit the go button, you can actually walk away while the machine does the work for you and come back and see a pass or fail criteria on that product. We also, because this is an automated system, track all the data from that test. So when we're running a pressure test, we'll track all the pressure versus time data, and then at the end of that test, we'll save that data, and you can actually download that off the unit and print out either a paper copy or an electronic copy of a test report certifying that your test unit has been completed. So one thing that's important to note on this system, we actually have a unique pressure testing profile. That's actually a patent-protected technology that we have, where anyone who's run a pressure decay test will be able to understand that it's very difficult to hit a target pressure exactly. So for example, if you're running a pneumatic test and you want to run at 10,000 psi, you might drive that pneumatic pump up to 10,000 psi, and as soon as you turn the air pressure off to that pump, the system's going to relax, which would mean you'd ultimately see the fluid pressure drop a little bit. So let's say hypothetically in this case it drops to 9,000 psi, and then you're going to try to do your pressure decay test there. What we can actually do is we have a very unique algorithm that'll run through a series of pressure ramps and decays, and we can lock in on that desired pressure point within 1% of the set point. Once we achieve that, then we'll start that pressure decay test, and we can watch the pressure slowly decay over time. So it's a really accurate way to do that test, and it's also very easy to set up. So it takes a lot of the guesswork out of doing a pressure decay test. So moving on, I want to go through a couple of the screens just to give you a highlight of how a user would interact with this system. So when you power the unit up, the first screen you're going to see is a login screen. If you type in either a couple numbers or initials or things like that, it's a 3-digit code that you can enter in, and what that'll be used as an identifier of who's running the machine at that time. So when you ultimately have that test report at the end, it's going to be able to tell you a certain user logged into the unit and ran that test. Next screen you'll be on is the manual run screen. So you can see here you have your gauge. This is, just like any analog gauge, as you increase pressure, you're going to see that needle react accordingly, very similar to a manual gauge that's out there. Manual mode, you can hit this minus button or plus button to increase your pressure, and you'll see a percentage number change over to the right, and that is 0 to 100% of the air pressure allowable from your system. So if you have a 0 to 100 psi system, if you hit this plus button until that read 50%, you would put 50 psi of air to the pump, and depending on the pump ratio, you would drive to that specific pressure. If you then come and hit the stop button, that'll automatically bleed the pressure off back down to 0. You'll also notice there's some buttons on the bottom of this screen. There's a house, that's the home screen, that's this manual run screen. The chart will get you into our automated pressure test function where you can track pressure versus time data. The gears are your setups, so there's various machine parameters and test setups that you can perform. The red stop button is just what you'd think it would be. It's stop, it shuts the air pressure off to the pump, and it'll bleed the pressure down to 0 psi. So moving on, just give highlights of a few of the pressure testing screens. So we talked about the manual run mode. Now we'll give just a little overview of the automatic pressure mode. So if you push this button to second button from the left, which is the charting functions, you'll be in the automated pressure test screen. So this is a pressure on the y-axis versus time on the x-axis. So as you run a test, you'll actually see your pressure curve increase or decrease accordingly depending on what you're asking for. So to set that up, you push the gear button. There'll be a few icons that'll ask you where to go. You're gonna enter pressure test, and it'll take you to a screen where you can enter your test. So if we want to set up this new test, we would hit the new test button. It's going to allow us to enter a name for that test. And then we can do various set points. A set point is a pressure we want to drive to. And we can set numerous ones of those. We can set up to 30 pressures in one given test that we want to drive to. So let's say hypothetically you want to drive to 5,000 psi, as we show here. That would be one set point. We'd drive the pump up to 5,000 psi, and then we would do something, maybe a hold test, a decay test, something like that. If we wanted to do a follow one automatically after that and run up to, let's say, 10,000 psi, for example, we'd hit new set point, and it would give us another opportunity to enter in one of these values. So the next screen will show some of the details there. So in this case, the example is for 5,000 psi, but this is a hold test. So it's saying let's run to 5,000 psi. The time that we want to run that for is 15 seconds, and we want to hold pressure. Hold pressure means that we're going to keep air pressure on the pump. So when we run that pump up, we are going to very precisely maintain exactly 5,000 psi on that test. We also have two other options for how you can run a test. The next one is decay. So what that'll do is it'll, again, allow you to drive to a pressure for a certain amount of time, but it's going to do a decay test. So we're actually going to run up to that pressure, and when we hit 5,000 psi within 1%, we're going to turn off the air to the pump. So we lock the system down, but we're not artificially maintaining pressure. So if you have a leak in your system, you're going to see that pressure decrease over time. And this decay allowed will allow you to enter either an amount of PSI or a percentage of the max pressure rating that if you exceed that on a leak decay test, then we'll classify that test as failed, and we'll finish the test, and we'll notify the user that the unit under test did not meet the decay test. A third method of test that we have is interact. And what that will allow you to do is drive to a pressure and hold at that pressure, and then it'll pause the test. And a screen, a pop-up window will show up on the screen, and it'll say, do your interaction. It could be a visual check or a manual operation. A visual check might be, you know what, I want to pause a test, and I want to physically look at my piece that I'm testing and see if there's any fluid leaks that I can see. A manual operation might be, I'm testing a needle valve, and I want to actually open the valve and see something happen and then close the valve again, and then when I'm done, start the test again. So think of it as a way to pause a test, do something, and then restart the test again. So from a system setup perspective, we have a lot of different variables you can enter, but the two I want to key in on this training is overpressure limit and gain. So overpressure limit is going to be an overall global variable on the system that's going to protect you from overshooting. So if you think of, if you're manually running a pneumatic pump right now without any kind of automated system, and you run a bunch of air pressure to that pump, you could actually exceed the target pressure that you're trying to go to because it'll run up to pressure really fast. In this case, we can monitor that, and we can put a limit on what's a safety over limit protection that you want. So let's say, again, some of our examples in the past were for 5,000 PSI. Well, in this example, we typed in 943 PSI as an overpressure limit. So what that'll do is if it ever detects that you've went 943 PSI over your setting, so in the case of those tests we were running before, it would be 5,943 PSI, we'll shut the system down and protect your unit from getting damaged. So think of it as like an overall governor on the amount of pressure that you can generate on your system. Gain is also a very important unit because that controls how fast the system runs. So you see it all the time. Everybody wants to run a pressure test as fast as they can. But depending on how much volume is contained inside the unit that you're testing, you might be able to build that pressure really fast, or it might take a long time. So if you were testing a very small piece of piping with a gauge on it and you wanted to do a gauge test, you're going to have a very small amount of volume where you can build up pressure really fast on your pneumatic pump. But if you're testing a large valve that maybe has an internal volume of 4 or 5 gallons, it's going to take a long time for that pump to run and build that pressure up. So what we can do, this gain is an arbitrary number 1 to 10, and that controls the speed that we'll control the air regulation at. So if we're testing a very small volume, we'll want that number low, say for example number 1, because we're going to want to control that rate of change of the air to the pump very slowly so we don't spike the pressure and overshoot. If you have a very large volume, set that gain to a higher number, and we'll speed up the air regulation so we can build up pressure faster. So think of gain as it's kind of a balancing act of the likelihood of overshooting versus the speed to build pressure. If you're overshooting your test value, you're going to want to decrease your gain value. If it's taking too long to build pressure to your desired set point, you're going to want to increase your gain number. So last thing on system setup I want to cover today is test results. We talked about how when we're running an automated test, we're tracking all that data and we can generate a copy certifying that test as completed. So if you go in your system setup, there's a button on here and you can transfer all your pressure test data simply at the push of a button. It'll download it to a USB stick, and then you can hook it up to your computer and download all those files. So I do have a slide that I'll be showing in a minute that'll go into that in more detail. Last thing I want to touch on setup is we do have the ability to control a dump valve or a fill pump on the system. If you want to speed up your system, these are on-off air type of controls. You're going to run an air solenoid that will turn the signal on and off to run either a pump or a pneumatically actuated valve that you could use for bleeding off pressure on your system or controlling a fill pump. So for example, you could say, you know what, I want to turn on a fill pump. I want to run a low pressure pump and fill up a very large volume. And then when that volume is done, it'll shut the fill pump off and it'll turn on your pressure pump and do the pressure test. So now I'll cover a little bit about the automated test report feature. So we talked about on the touch screen, you can scroll through a few screens and push the export pressure test button. What you actually have to do to get these tests off the unit, you have to open up the cover and insert a USB stick into the PLC. So there's a USB slot that looks just like any typical one on a computer or laptop or phone or anything like that. Step 2 would be scrolling to that screen that's in the setup program of the gears and press the transfer files button. That's going to download all the test reports on the unit that they're going to be coded by a date and time and a serial number of a file. You can then put that USB stick into your computer. And we have an Excel-based program that's an automated macro that will provide on a USB stick with the unit that you can run that Excel file, and there'll be one button on there that says process the files. You can push that button. It'll pop up a window to ask you to select the file based on your date and time of your test that you want to run, and it'll open up the file. So this will still be in Microsoft Excel. You can enter in a few critical things about your test, for example, your customer name, what's the name of the test, the part number, things of that nature. And then when you hit the done button, it'll generate a PDF copy that'll show you your certification, your information about your part, your pressure versus time data. You can sign that off so the operator can sign off that test. And then subsequent pages of this report will be all the Excel-based data for the time-based pressure versus time. So from a sales perspective, the way we're going to be offering this unit for sale is there's going to be 20 top-level systems. That system is going to contain the control box. There's one version of that, a pressure transducer cable, and a power cord. So the options are really pick your pressure transducer and your power cord. We have 5 different pressure transducers that we offer, ranging from 10,000 psi up to 75,000 psi. And power cords are region specific. The unit can run on either 120 or 240 volt power, standard residential or industrial power. We're offering power cords in USA, UK, general European, or Australian 240 volt setups. From a dimensional standpoint, the unit's fairly small. It is approximately 18 inches wide, by about 16 inches tall, by about 8 inches deep. So the goal is to have a box that's fairly small in size, but very powerful, that can mount right to the wall, right to the side of an existing manual test bench, and not take up a lot of room. And just remember, by hooking up air and power to this unit and a pressure transducer, it's all you need to do to automate your pressure testing.
See if you have any questions in the chat room. If you have them, again, please enter your questions in the chat box. Okay, looks like we have a few questions here. The first one, will this system slow down my test? So the question is related to if I hook up this system to an existing pump, will it slow down my test, or what should I expect?
So in the case of this system, it's capable of supplying 85 SCFM of airflow to a pneumatic pump. So as long as that's enough to run your test, which a lot of our testing and trials with customers in the field verified that that was plenty of air pressure to run as fast as they've seen, as long as that's enough airflow available, you shouldn't have any problems of this automated package slowing down the operation of your pump compared to a pure mechanical setup. So if you do see, remember we talked about the gain setting as well, if you do see this running slower than what you desire, the key is to remember to go into that gain setting and increase that value up to make the system run faster.
Okay. Next question. Can I run this system from a PLC?
So in this case, this is an automated package. This unit is the PLC. So if you ever get that question, remember we're providing a PLC with this. It is possible to hook this PLC system up to a computer if you want to run it off a computer, but all the number crunching, all the automation is embedded inside that touch screen of the unit. So this is a plug-and-play automation system.
Okay. Next question. Can I use this system with any pneumatic intensifier pump?
So in this case, we're not limiting the operation of this to any sort of HIP only type of equipment, for example, a Sprague pump. This will work with any brand of pneumatic intensifier pump. So if you remember when we talked about how does this system work, we're controlling the air pressure to the pump and we're monitoring the fluid pressure after the pump, and by controlling the combination of those two items, we can run the system. So it doesn't matter what brand of pump you run, we can hook this up to. It doesn't matter if you have a custom bench built from, a custom OEM skid builder or just a pump that you want to plug into, we can make this system work with it.
Next question, can I use my own calibrated transducer with the PT2020?
So yes, you can. So in addition to the 5 transducer options that we have, we also have the ability where you can connect your own transducer provided it runs on a 4 to 20 milliamp signal. So we can provide the signal to power that transducer and we can read it as long as it talks over that 4 to 20 milliamp signal. And we also have a calibration program where you can enter in your calibration values for that specific transducer and it'll work. So the example there would be perhaps you're a manufacturer, you have calibration records for your ISO certifications that you have to have. If you have those transducers on site already, we can make it work with the PT2020.
Okay, I think that's all the questions we took today. We'd like to thank everyone for their attendance, and just keep in mind that this presentation is also recorded and can be accessible at a later date. Thanks again and have a good day.